Welcome. This video is about classifying matter. It's found on page 80 to 81 or 84 to 87 in your textbook. So far what we've learned are classifying matter according to their states, a solid, liquid, or a gas. Those are classified by the states of matter. But this lesson isn't on that. We're classifying matter in a different sort of way. We can have a whole big system, and this whole slide is what I'm going to talk about. That's why I don't have my picture in this one, because I'm going to fill up the whole slide. So let's think about matter, and we can separate it into two big parts, pure substances versus mixtures. Anytime if I go too fast, please put pause. You can also print this slide out if it helps. So taking a look at a pure substance. Pure substance is one type of substance, and that differs from a mixture, which is two or more pure substances which are physically mixed together. I'm going to stick to the pure side here for a little bit, which has one type of substance, and we're going to look at the differences between an element and a compound, both of which are a pure substance, but they're entirely different types of pure substance. Elements you've already heard about, we've talked about them a lot. They're the simplest form of pure substance. Elements are made of atoms, and the periodic table of elements tells you about all of the different kinds of elements. If it's not on the periodic table of elements, it's not an element. Here's some examples. Let's go to the aluminum, Al. Aluminum is a type of element. It's on the periodic table. Zinc is also a type of element on the periodic table. Oxygen is on there, but when you see oxygen, you don't ever see it as just an O. It'll have O2. That little 2 means there's two O's stuck together. This is still an element. It's just two atoms of the same element, but we'd still classify it as oxygen, so it is an element. Similar to P4, phosphorus, it has 4 atoms of phosphorus stuck together. It's still an element though, because it's just phosphorus. If you notice the two blue circles, remember when we were coloring pictures according to Dalton, and we used different colors for different types of atoms? Well, here I've got two blue circles because it's representing the same atom, the blue atom. There just happens to be two of them. So this is a picture of an element. Elements differ from compounds in the fact that you have to have two or more elements chemically combined to make a compound. This word chemically is meaning bound for life. It's stuck there for life. And we're going to talk more in this chapter about how that happens, so it'll make more sense. But let's look at some examples of compounds. There are things like CO2, carbon dioxide. Those are two or more elements, C and O, carbon and oxygen, and they're chemically, that means stuck together. Those O's are attached to the C's for life. Sodium chloride is another example. Notice it's the name. Sodium is an element. Chloride or chlorine is an element. Together, you can see they're stuck together, they make a compound, sodium chloride. We can show this as a picture. You can see there's 3 different kinds of atoms, 3 different colors. And those atoms are touching each other, and that's one way we can show in pictures that they're chemically combined, compounds. Let's go to the other side, mixtures. Those are 2 or more pure substances physically mixed together. I can see I've got 2 types of these also, heterogeneous versus homogeneous. That word homogeneous mixtures are also the same as solution, so you can use those terms interchangeable. Let's go on the heterogeneous side first. Heterogeneous mixtures, composition is not the same throughout. That word composition is basically how does it look? It doesn't look the same throughout. Here's some examples. I think the left one is like a bacteria picture. Bacteria, there's no element bacteria or compound bacteria. There's just bacteria, and it's made up of bazillions of different atoms. And those atoms are like elements or compounds or any kind of mixture of the two. But I can see that when I look at this green blob, that doesn't look the same everywhere. It is not the same throughout. It's a heterogeneous mixture. Fire truck definitely doesn't look the same throughout. It's different. It's a heterogeneous mixture. And sandy water is also a good example. If you have a glass of sandy water and you kind of swirl it, sure, you can get the sand and the water to kind of look the same throughout at all times. But once you let it settle, the sand will go to the bottom, the water will go on top. If anything of a mixture settles, you know that the top and the bottom won't look the same. It's a heterogeneous mixture. Heterogeneous mixtures differ from homogeneous in that homogeneous looks the same throughout. Composition is the same throughout. For an example, salt water. If you had a glass of salt water, the salt doesn't settle to the bottom. It's salt water everywhere. So salt water is an example of a homogeneous mixture. It looks the same throughout. It looks clear everywhere, just the salt is dissolved in the water. They're not chemically combined, the salt and the water, they just happen to be mixed together. to make salt water. I'll see you tomorrow, so please bring your questions and fill out the Google form.